morning everyone, I am Baracena, and in this video, we will discuss the basic concept of Weibull distribution, the probability function, the effect of shape parameter, and the application example.
First, let's have a little background for Weibull distribution. So what is the Weibull distribution? In probability theory and statistics, the Weibull distribution is one of the most important continuous probability distribution, meaning that Weibull distribution has a range of values that are infinite and therefore uncountable. It was first introduced by Weibull in 1939 when he was studying the issue of structural strength and life data analysis, and was formally named after him later in 1951. There are two included parameters. First, the two-parameter Weibull distribution has a scale and shape parameter. Second, the three-parameter Weibull includes a location parameter. Note that gamma is the shape parameter, alpha is the scale parameter, and eta is the location parameter. Now let's talk about the two-parameter Weibull distribution. Occasionally, a third parameter is added, which will be tackled later. Here, the scale parameter is denoted as eta, also called the characteristic light parameter. The shape parameter is denoted as beta, also known the Weibull slope or the threshold parameter. One of the nice properties of the Weibull distribution is the value of beta. When beta is less than 1, the distribution exhibits a decreasing failure rate over time. When beta is equal to 1, the distribution has a constant failure rate. And when beta is greater than 1, the distribution exhibits an increasing failure rate over time. Probability density function. When t is greater than or equal to 0, then the probability density function formula is ft is equals to beta time raised to beta minus 1 over eta raised to beta times e raised to negative t over eta raised to beta. A plot of PDF provides a histogram-like view of the time to failure data. This is just an example of Weibull distribution shapes. The cumulative distribution, or CDF, provides the probability of failure up to time. This is the formula. Ft is equals to 1 minus e raised to negative t over eta times beta. This is an example of Weibull failure rate function. Ft is the cumulative probability of failure from time 0 till time t. Very handy when estimating the proportion of units that will fail over a warranty period. Reliability at time RT will be RT is equals to 1 minus Ft. Since Ft is equivalent to 1 minus e raised to negative t over eta times beta, substitute natin yung value ng Ft sa equation 1 para makuha natin yung pinaka-equation ng RT. RT is the chance of survival from time 0 till time t. Instead of looking for the proportion that will fail, the reliability function determines the proportion that are expected to survive. Hazard rate function. The hazard rate function is given by Ht is equals to Ft over Rt. Since the value of Ft is equals to beta times time raised to beta minus 1 over eta raised to beta times e negative t over eta times beta, and RT is equals to eta raised to negative t over eta times beta. So, ang gagawin natin is substitute lang natin yung value. Then after that, cancel out yung magkapareho ng given para makuha natin yung pinaka-value na beta times time raised to beta minus 1 over eta raised to beta. Now, dako tayo sa application example. The problem is, we will consider the same example of tires. The company has supplied 12,000 tires to a superbike manufacturer. What percent of tires are likely to fail within a warranty period of 5,000 kilometers if beta is equals to 2.5? The scale parameter is estimated at 8,000 from the past field data. This is the solution. Since Ft is equals to 1 minus e raised to negative t over eta times beta at 5,000 kilometers with beta is equals to 2.5 and eta is equals to 8,000. Now, we're going to substitute the value of time and the value of eta and also the beta, which is Ft is equals to 1 minus e raised to negative 5,000 over 8,000 times 2.5, which will give us the answer of 0.266 or 26.6% tires are expected to fail. As the batch size is 12,000 and 26.6% of 12,000,
Now, let's tackle the three-parameter Weibull distribution.
3,188
There is
tires
also a three-parameter
are
version
likely
of the Weibull
to fail.
distribution, which adds a location parameter gamma. Again, gamma is the shape parameter, alpha is the scale parameter, and eta is the location parameter, also called the waiting time parameter or sometimes the shift parameter. Note that eta, the time to failure, is not included in two-parameter version. But here, beta is the shape parameter, alpha is the scale parameter. The probability density function. Weibull probability density function are both common use in two-parameter PDF and three-parameter PDF. The probability density function of this distribution is fx is equals to beta over alpha times x minus gamma over alpha times beta minus 1 times e raised to negative x minus gamma over alpha times beta, where x is greater than or equal to gamma. The shape parameter is greater than 0, which is the beta, and alpha, the scale parameter, is also greater than 0. The cumulative distribution function is or CDF is fx is equals to 1 minus e raised to negative x minus gamma over alpha times beta. The inverse cumulative distribution function is IP is equals to alpha times negative ln 1 minus p raised to 1 over beta plus gamma.
And that's the end of our discussion for the Weibull distribution. Thank you and have a nice day.